Okay, we'll just got a quick recap on factorising when there is the coefficient of x squared. So we're talking about expressions like v squared minus 6v add on 8. How can I find out what this needs to be to put it into two brackets? And the reason we need to do this is what we do with this number, we also really ought to do with this term. And what we do with this number is we think, right, what things can multiply to give me the 8? So we've got 1, 8, 2, 4. No others, no 3, 6 or anything else. We don't tend to try factorising with anything other than integers normally. And then we look at this sign, and the sign there says they must be the same. So that means we're going to either add or subtract. No, we're going to add the size. So the size is by addition. And what we want is the pair of numbers that when we add them, we get this term. So we're looking at 9, and I've got a positive 6. Now I know I actually want this to be a minus 6. So to turn this into a minus 6, we change the signs of all terms leading up to it. Minus 6, minus 4, minus 2. These two numbers are the parts that multiply to give me the plus 8, so we're all 1. These are actually called roots, and they're called alpha and beta, Greek terms. So in this case, alpha times beta must equal my number on the end, and if you're familiar with something that will come up later, the quadratic formula, alpha times beta must be equal to the c, and alpha plus beta is what gives me my value of b. Okay, so I must have those two things being true. In this case they are, so therefore my bracket is v minus 2 and v minus 4. That's the logic we were using. Let's do another one with a different negative sign on it. So let's go for w squared plus w minus 210. Lovely big numbers, I like to see them. We've got lots of possibilities here. Now you might be able to jump to some numbers quite quickly, and that's what factorising is about. It's being familiar with types of numbers. Now let's just put some down first. We've got things like 21 and 10, but they're different signs. So this sign now means difference of these two values. So I tried 20 and 10, and that gives me a difference, which is 11. What else could there be? Well, no, there could be 3 and 70. Of course, that's going to be too big. And the difference there is 67. So actually I did 70 minus 3. And that means one of these is different. Okay. So a little trick for you was when these two, when we're doing a difference one, we know they must be close to each other. So a good candidate is they're going to be around the square root of 210. This is a thought I can make about these numbers. And if I know the square root of 210, square root of 210 is 14. So let's try 14 times 15. Does that give me? First of all, let's check 14 times 15. That's going to be half of that times 10, 70 times 3. So yeah, that is 210. So that gave me my candidate numbers. I've got 15 and 14. The difference is 1. And that is the correct sign. So I leave everything as it is. Create my bracket, w plus 15, and w minus 14. So that's how you can deal with the coefficient when the coefficient is just x.